story of balloons and airships all started with the initial thinkings of an individual named Joseph Michel Montgolfier. He was observing drying laundry hanging over a fire. As the hot air hit pockets inside the fabric, it lifted the laundry up. Joseph began contemplating how air attacks on particular fortresses, such as Gibraltar, could be susceptible to air attacks if this same principle could lift troops over their walls. This is a painted drawing of the first hot air balloon created by the Montgolfier brothers Joseph and Jacques. Their design used a combination of sackcloth and thin layers of paper which held the hot air that was created by wood fire underneath the entire balloon. Initially, royalty and the public were so impressed by their early unmanned tethered flights that they wanted to demonstrate a flight with living things that was untethered. The king initially suggested 2 criminals, but the brothers decided on animals. The first manned flight occurred on September 19, 1783, involving a sheep, which was thought to be equivalent to a human subject, a duck, and a rooster. It was a success as the trip lasted 8 minutes, traveled 2 miles, and reached an altitude of 1,500 feet. The principle behind a hot air balloon or even a dirigible is buoyancy, which is an upward force exerted on a body by a fluid that is less dense than a fluid that is surrounding the same body. If the buoyant force is greater than the weight of the object trying to rise, then the object will float. This buoyant force can cause balloons and dirigibles to rise by either hot air or gases that are lighter than air, such as hydrogen or helium. Unfortunately, for loads such as a person, which are heavy, a larger amount of gases is needed. Basically, the larger the balloon means a larger amount of air is displaced by a lighter gas that has very low density and can cause the upward force to increase. However, there is a limit to how a balloon can rise because of the lack of air at higher altitudes. The balloon's buoyant effect stops and the balloon maintains this maximum altitude. A smaller balloon will have a lower altitude limit because less air is displaced and less overall buoyant force. This data shows an example of the total mass that makes up a modern balloon, which holds approximately 100,000 cubic feet of air. As you can see, the total load is about 7,517 pounds, but minus the buoyant air, it's about 1,595 pounds of load. As long as the buoyant force can go above the previous weight mentioned, the balloon will float. Now this next table shows the weight of the air as it changes temperature. At 210 degrees, the volume of air can apply 1,595 pounds, the same as the total load before. This makes for neutral buoyancy, which means the balloon will be filled but not lift off the ground. To actually get lift, the temperature in the balloon typically increases, and at 250 degrees Fahrenheit, the balloon can now increase the lift to 1,912 pounds of force. There are other factors that can control the balloon's lift, such as humidity and outside air temperature, but that won't be discussed in this section. Today's balloons, much like Montgolfier's balloons, use hot air, but as technology has improved, the balloons have become more sophisticated. The diagram shares the different parts that allow hot air balloon pilots to fly. The envelope, which is primarily made of nylon, displaces the more dense air surrounding it with the hot air. At the very top is a parachute valve which opens to allow the cooler, more dense air outside to mix with the warmer air and causes the balloon to descend. This envelope is stitched in panels that are combined with their edges to make gores. Nylon is a flexible material that is lightweight and has a high melting point. The very opening of the balloon, called the skirt, is made up of more nylon that is covered with a protective material to prevent the edges of the envelope from scorching. Liquid propane is the combustible fuel used to heat the air and is stored in tanks located within the basket. There are lines that lead from the tanks to the burners. Some of the fuel is ignited by a pilot light and heats up these series of tubes. The tubes are holding liquid propane, which is getting hotter from the initial ignition. As this liquid changes to a gas and exits the tubes, it's at a higher temperature that will cause an even better combustion that can heat the air to a very high temperature and requires less fuel. These burners could be single, double, or even quadruple in number, depending on what size balloon that you're using. The final item is the wicker basket. Why wicker? Because it's flexible and fairly lightweight material. If the basket was made of a rigid material, the passengers would experience quite a landing because the wicker also has the purpose of absorbing some of the energy involved in landing. Now I hope you learned something today that you may not have known about hot air balloons, and I know that you were anticipating a talk about dirigibles, also known as airships, but that will have to be for another time. Thanks.
As she bounces through the blue sky, everybody's building up a big blue balloon. They made the string from fairy wings and golden dreams, goes. No one knows about the blue balloon.